We're here in section 1.2, and in this video, we're going to look at an introduction to sampling. Now, quick note before we do, there is a part of the textbook here that looks at graphs and charts. You can skip over that. I think it's a couple pages of the text. We're going to really dig into graphs and charts in chapter 2. So for right now, just skip through that and read the part that comes after. So we really want to look at this intro to sampling. Okay, and sampling is the process of selecting your sample group from within the overall population. And we want to be able to do that in the best way possible. So the main goal of sampling is to have a sample with the same characteristics as the population it is representing. We call that a representative sample. And this is because we're trying to learn about the population from observing the samples. So we really want those two things to be closely matched to each other, to have these same characteristics. So that's our goal. And often we're going to do this by using random sampling. In random sampling, each member of the population starts with the same chance of being selected for the sample. So this keeps things equal across the board. It's just random selection. You have just as good a chance as the person next to you of being selected to be part of this sample group for the study. We want to just keep things nice and balanced like that. And there are different methods for random sampling. That's what we're going to look into here. And the first one we'll look at is probably the quickest and the easiest. It's called the simple random sample. And in a simple random sample, you are just going to select randomly from the entire population. And depending on what level of technology you have or how fast you need to come up with the sample, there's some different ways to do this. A classic is just to put everybody's name in a hat and draw names from the hat. We do this at work often to pick people to be on committees and things like that. If you want to be a little more sophisticated about it, a little more technological, you could use something like a random number generator. These are available free online, on apps, on your calculator, and it's just going to pick random numbers from whatever range of numbers you give it. So here, for instance, we've got a little population of 15 people. Let's say they were numbered 1 through 15. And we've selected person number 1, number 5, 7. We've got person 11 there and person 14, just randomly selected from the population. Okay, so that is the simple random sample, our first method. Then we have the systematic sample, which adds another little dimension to this here. In the systematic sample, we still work with random sampling, so we're going to randomly select a starting point. Okay, so not everybody's being completely random selected here, but we're going to randomly select a starting point, and then we'll select every nth member of the population after that. So in the little diagram, we've randomly selected to start at person number 3, and then we're going to skip an even or equal number of spaces to get each sample member after that. So we go from 3 to 7 to 11, 15, 19. And with a little quick math, we can see that each time there we are adding 4. Okay, so when we say we're selecting every nth member, we're picking every 4th person to be part of the sample. So our n value here equals 4 to select every nth member. You'll also sometimes see this as K if they want to use a different letter. It means the same thing. You're just selecting every some number of people after your starting point. Okay, I think the book uses N though, so we'll stick with that for now. So there's a systematic sample. It's got random starting point and then a very systematic approach after that. Next is a stratified sample. Here we are going to divide the population into subgroups called strata and then select a proportionate number of members from each stratum to be part of the sample. So the two vocab words there, strata is the plural version. So like all three of these groups, those would be called the different strata. But then if you're just looking at one subgroup, it is called a stratum, kind of like data versus datum. We have strata versus stratum. Okay, so you can see over here, it's kind of small, but this is stratum 1, stratum 2, and stratum 3 along the side there. And you'll notice that they're grouped by some attributes. So each stratum's members share some attribute. In this case, they're being divided by shirt color. We've got the red shirts, the blue shirts, and the yellow shirts making up our three strata. And so we've divided the population by that attribute. And then you can see we're going to select different members from each stratum. We've got these two guys from stratum 1, these two guys here from stratum 2. And then if we were being truly proportionate, it looks like we should probably have selected 2 individuals from stratum 3. So I would like to add another little person there to be selected. That way we're selecting equally, since they're equal sized strata. Now, notice that it does say you'd select a proportionate number of members from each stratum. So if one of these groups was like a lot bigger than the other, you could pick more people from that group. Again, we're just trying to make a sample that's going to represent the population. So we want to keep things proportional. Okay, so that's a stratified sample. And then very similar, but somewhat different, is the cluster sample. In the cluster sample, we're going to divide the population into subgroups again. Now they're called clusters. So we have 5 little clusters here in our diagram. And then select several different clusters. All of their members will go into the sample. So we've selected cluster 1, cluster 4, and cluster 5. And all of their members from those 3 groups are going to become the sample. All right, clusters 2 and 3 just kind of get left out in this case. We've just randomly selected those 3 clusters to make up our sample. So the big difference between stratified and cluster samples is how we are selecting the sample members, because both of these divide the population into subgroups, but the stratified sample is going to take some members from every group, every stratum, and the cluster sample really flips that around. It's going to take every member, but we've only selected some groups. Okay, so there's the big difference. Stratified takes some members from every group. A cluster sample takes every member from some groups. Okay, so those are our four main methods of random sampling. In the next video, we'll look at some methods of not so random sampling and dig into a few more ideas about samples.